Well, congratulations for making it to the very last unit, or the last topic in Unit 5. And this one really doesn't have a whole lot with coordinate geometry per se, but it's more of a technique on simplifying this radical that we see a lot of radicals in the unit, the coordinate geometry unit. So it's kind of nice to just have an idea and be able to simplify these radicals in the proper method. And rewriting and simplifying radicals is actually not overly difficult. It is kind of time consuming. But one of the things we have to do is I just have a couple of steps. And I've done it this way for years, and it seems to work out, and it's not too bad. And the first thing is I rewrite the number inside the radical as a list of its prime factors. And a hint of that is do a factor tree if you need to. And then I determine the size of the groups by looking at the index of the radical. Right? It's the little number in the check. Now, a lot of times you don't see that little number in the check mark, and that's because it is a 2. That's what we call a square root. And if you have a square root, then that index is called a 2. And if you have a cube root, you'll see an index in there. You'll see a 3 or a 4, so on and so forth. So once I determine the size of the groups, the index will tell me that. I group them up with that many terms if they're the same. And once I do that, I move them to the outside of the radical. And then I multiply all my outside terms together and leave it outside, multiply all my inside terms together and leave it inside. So let me show you what that looks like. Right? It's easy to read through those steps. It makes much more sense when you actually just see it being done. So the first thing I'm going to do is I'm going to do the prime factorization of 48. So 48, if here we go, 48. So 48 is 2 times 24. Well, 2 is prime, but 24 is not. 24 breaks down to 2 times 12. 2 is prime, but 12 is not. 12 is 2 times 6. 2 is prime, 6 is not. 6 is 2 times 3. 2 is prime, and 3 is prime. So when I rewrite 48, it is going to be 1, 2, 3, 4 2's, and 1 3. And that's still in the radical. So 4 2's and 1 3. And I get that from the factor tree. Now, the index on my radical, right, it will be right here. Right? You don't see a number in there because this is a square root. So this is a radical 2. All right? And that means I need to group things in pairs of 2. So I have these first 2 2's can be grouped together, and I can pull a 2 out because of it. And look for another pairing of 2. Well, here's another pairing of 2, so I can pull a 2 out. And there are no other pairs of 2. So now on the outside, multiply everything on the outside. I don't see anything here, so I don't have to worry about that. But I have 2 2's on top, and 2 times 2 is 4. Now inside the radical, these 2's are gone. They got pulled out. So I don't worry about them anymore. What is still left in there is a 3. So my final answer is 4 radical 3. That is the simplified radical. All right, let me try another one. 120. Factor tree of 120. That's 12 times 10 is 120. Well, 12 is 4 times 3. 3 is prime, 4 is not. 10 is 2 times 5. 2 is prime and 5 is prime. 4 is 2 times 2. 2 is prime, 2 is prime. So when I rewrite 120, I have 1, 2, 3 2's. I have 1 3 and 1 5. Again, I check my radical. That is a square root, has an index of 2. So I have to find pairs of 2. So there are 2 2's. After this, there's no more groups. No more groups. So on the outside, again, I see nothing out here, so I don't worry about it. But I have a 2. A 2 made it out. Inside the root, these are gone, because I've pulled that out. Inside is 2 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30. So radical 120 reduces to 2 radical 30. And that's how I simplify radicals. All right, example 3. The only difference is now I've got a variable in there. So 80 is 8 times 10, 2 times 4, 2 times 5, 5, 2, 2, 4 is 2 times 2. So when I rewrite radical 80, I have 1, 2, 3, 4 2's and 1 5. And then I have x to the third, which is 3 x's. Let me get that out of the way. All right, so what kind of a root is this? Well, it is a square root. All right, I check my little index there. It's still a 2. I don't see it, so I group everything in groups of 2. So there's a group of 2, so a 2 comes out. Here's a pair of 2's, so a 2 comes out. There are no pair of 5's. Here's a pair of x's, so an x comes out. I have no more groups of 2. So what made it out? 2, 2, and x. Well, 2 times 2 is 4, times x is 4x. And then inside the radical, those 2's are gone, these 2's are gone, these x's are gone. What is left? It's 5 times x, or 5x. So the simplified radical would be 4x radical 5x. Now let's take a look at number 4. It says 50. So 50 is 5 times 10. 5 is prime. 2 times 5. They're both prime. So when I rewrite my radical, 50 is a 2, 2 5's, then I have x squared, so 2 x's, 3 y's. Check my index. My index here is a 2, so I need groups of 2. So there's a pair of 2, or a pair of 5's. There's a pair of x's. There's a pair of y's. So what has made it out? 5xy. What is still inside the radical? Well, the 5's are gone, the x's are gone, the y's are gone. I'm just left with 2 times a y, so 2y. So simplifying radical 50x squared y cubed would be 5xy, radical 2y. Now, a lot of these topics are not necessarily geometry. I do want you to understand that. These are numbers that are quite a bit bigger. And with the variables, this is almost an Algebra 2 topic. But since you're trying to get an A, I figure you might as well extend your learning a little bit. It's something you're going to have to learn at some point anyhow. All right, so this next one, yikes. This is a big one. So this is 686. I know this because it's even. 686 is divisible by 2. This is 2 times 343. And 343 is not divisible by 2. 343 is not divisible by 3 evenly. 343 is divisible by 7, however. So 7 times 49. 7 is a prime number. 49 is 7 times 7. So there's my prime factorization of 686. So notice how this problem is a little different. Now you see an index in there. You see a little 3 inside that check mark. So I have 2 times 7 times 7 times 7. And what this little 3 right here tells me is now I don't group them in groups of 2. I need 3 terms. So here are 3 7s, so a 7 comes out. So what made it to the outside? A 7. What is still inside the root? And that is a third root, or what we call a cube root. Well, the 7s are gone because I pulled them out. The only thing left inside is the 2. So my answer is 7 cube root of 2. Alright, and the last one. This is going to be another nasty one. 2592. Well, it ends in a 2, so I know it's divisible by 2. And that is 2 times 1296. Well, 1296 is even, so it will also be divisible by 2. 648. 648 is even, so it is also going to be divisible by 2. 324. 324 is even, so it is going to be divisible by 2. 162. 162 is even, so it is going to be divisible by 2. 81. 81 is 9 times 9. 9 is 3 times 3. This 9 is also 3 times 3. So when I rewrite this, fourth root. Alright, what do I have? I have 1, 2, 3, 4, 5 2s. And 1, 2, 3, 4 3s. Then I have 5 x's. And 3 y's. So that is a whole lot of prime factors. Let me move that factor tree out of there now. And my index here is a 4. So now I need groups of 4. Have to have at least 4. 1, 2, 3. There's 4 2s. So a 2 can come out. Here are 4 3s. So a 3 can come out. Here are 4 x's. So an x can come out. And I don't think anything else has 4 of a kind. So what made it out? 2 times 3 times x. 2 times 3 is 6 times x. And then I have my radical, and this is a 4th degree. So all of these 2's are gone. All of these 3's are gone. All of these x's are gone. What am I left with? 2 times x times y times y times y. That is going to be 2xy cubed. So my final answer on a really challenging problem is 6x fourth root of 2xy cubed. So that is how you're going to simplify radicals. Again, I know that that is a little bit beyond the scope of geometry. You're not going to have anything like example 6 or 5 or probably 4 or 3 in the actual geometry OST test. But I look at it as if you are at unit 10 and you want to truly be a master of everything coordinate geometry, this is a skill that I think is going to benefit you greatly. So, as always, if you have any questions, please don't hesitate to ask. And congratulations on making it all the way through Unit 5, Coordinate Geometry. Have a great night, guys. See ya.